Hey, this is Dr. Graves with the CSUN Geography Department. This is a video tutorial using SPSS to do some basic statistics on crime data. I've already logged on to the My CSUN software, or the VSL, and the software that we're going to be using is SPSS. It changes, it seems, every year, so this says 25, but it could be something different in semesters beyond this one. So go ahead and click to open it, and after a minute or so it should appear. I'm going to cancel out this first screen. I'll close it and I'll maximize this screen. I'm going to click on File, Open, Data, Permit All Access if that shows up. And what we're looking for in the list of drives and folders is the geography share folder. So geography share is what we're looking for, and the data for this exercise is in Graves, forensic, click open, and correlation, click and open. And I'm going to demonstrate this using the 460 correlation in class file. Open. You always get this sort of background screen with SPSS. There are two screens, there are two windows you work in all the time, and so I'm going to nearly maximize this one. This is the data screen, and we're going to run just a couple of simple statistics in here today on this data, the crime data that we've been working with in another class or on another lab. So the first thing that I'm going to have you do is click on the Analyze drop-down menu, and we're going to take a look at some descriptive statistics. Click on Descriptives, and let's go ahead and just you can click on these one at a time or highlight them all, clicking Control or Shift and the bottom one. I'm going to move these over. Click on Options, and it's asking us which of these descriptive statistics would we like to use, and we're going to ask it for kurtosis and skewness, in addition to mean and standard deviation, minimum and max. So click Continue and click OK. And here we get a whole pile of statistics that we can use here. And if you look down here, we get mean, standard deviation, and recall that if the standard deviation is oftentimes very large compared to the mean, then we may be worried about the skewness. And so these skewness variables are the ones that we're going to have to sort of take a look at, and any of these that have large numbers as they approach 1.96, then we start to get worried about them being skewed. The kurtosis is a measure of the pointiness of the distribution of data around the mean. So that's all you have to do for right now. We're going to go and move this. I'm just grabbing that and sort of moving it to the side so we can look back at the data. We're going to use another tool or two here. Once again, a tool from the Descriptive Statistics. We're going to click on Explore. And for this one, let's just take a look at something like population. I'll move it over here to the dependent list. Ask what statistics do we want. The descriptives are fine, so make sure that's checked. And then we're going to ask it to give us a histogram. And you could leave stem and leaf too. And then normality plots, which is we're checking again for skewness to see if the data is normally distributed. Continue, and it's going to give us an output with both the statistics and the plots. Click OK. So here we go. It gave us the descriptives once again. Here's the test of normality. And in this instance, these tests indicate that the data is very likely skewed. And if you look at this histogram, that tells you that that is indeed the case. It's because it's the state populations of the United States, and as we all know, California is this weird outlier here. The less skewed data would be largely on this line, or have a nice sort of curve on this line. And here's the stem and leaf, and here we have California, the fifth state alphabetically, really jumping off the charts. So that's another way of doing it. Let's take a look at one more here. Oh, no, I don't want to do that. Let's click once again on Analyze, and then use the descriptive tools to explore normality. Let's pull population off, and let's look at something like, I don't know, gallons of beer consumed. Move that over. Once again, check for the descriptives and the plots, and click Continue and OK. And now we will have a case processing summary for the beer. Here are the variables, various descriptives. Take a look at skewness here, 0.647 versus what we got up here, and the skewness was 2.5 over that 1.96 threshold. As we scroll down here, now this looks more like a bell curve, and so when we look at the test for normality, we have this number 0.2, which is far greater than 0.05, so we know that this is acceptably normal, and we could use that data in most of the tests that we might run. For the state population data, however, if we wanted to use that, as I scroll back up to it, we may have to adjust the state population data and perhaps put it on a different scale using the logarithmic function to make it act normal, which is an important thing to learn how to do as we're moving towards regression analysis. The last of these tools that we're going to use today for this assignment is to click Analyze and Correlate. We're going to do bivariate correlation in this instance, and our variables here are going to, let's just put them all over here. We're going to check off Pearson and Spearman's, and we can do two-tailed tests of significance. Click Option. We can do means and standard deviation if you want. Click Continue, and we need to move these over. Highlighted them all, moving them over, and then click OK. We're going to get this massive printout of all sorts of things here. But what we were looking for is the correlation coefficients, and these with asterisks next to them suggest that there is a strong relationship between the correlation coefficient, Spearman's rho, and the population. And as we move through here, you'll notice that as you go down this way, there's a lot of 100% correlations. But you would want to look here, murder rate, as we move across the murder rate and the population, and then the female population, nothing there. Of course, murder rate in itself, there's something. And homicides and the murder rate, because they're the same thing, of course, are going to have a very high correlation. But then prisoners executed, here's median household income. It has a negative correlation, but it's not strong. Median age of the population, this sort of thing. As we go across, we can see which one of these variables seem to have something to do with murder rate. And that is pretty much all that I'm going to ask you to know how to do with this software. It's nice to use this software, SPSS, to prepare your data for more further analysis.